Hello everyone, welcome back to the channel. In this video, we will talk about another type of multi-agent system in LangGraph, which is hierarchical architecture. Okay, and we'll be implementing an end-to-end project using LangGraph. So before I start the video, I'll just like to reflect back to this playlist. So this is the LangGraph playlist which I've created, and I've been putting videos in this playlist covering different aspects of LangGraph, different topics of LangGraph, and each and every video I'm covering both the theoretical or conceptual part, and also I'm giving a sample project for each and every concept. So as of now, we have seen the introduction to LangGraph, then we have seen what is state graph, then we have seen how to create React agents using LangGraph, then we saw model context protocol. Then in the last couple of videos, we have seen two types of architectures. The first one was the network architecture, and the second one was supervisor architecture. So continuing in the series, today we'll be covering hierarchical architecture. Okay. So now, first of all, we'll start off with understanding the concept, and then we'll move on to a project. Okay. So let's get started. So first of all, we'll see the introduction. So first of all, let's imagine that you are running a research company. Okay, and you receive a big project, and let's say a typical task would be to analyze, let's say, smartphone sales data and create a detailed market report, right? So let's say this is a high level task which this company is one of the tasks which this company or this project is talking about, right? So we are a research company, let's say. So we receive one of the projects in which we have to analyze the smartphone sales data and create detailed market report. So now this entire task cannot be done by one person, right? So what would be the approach then? Then an ideal approach will be creating teams. Let's say there will be top level supervisor, or let's say a team manager, and inside under this team manager there will be different teams working, right? Let's say we have two teams here. So one of the teams, let's say, is expert in analysis, data analysis. The second team is expert in content writing, right? So this particular team can do data analysis, can find different statistical measures, can give inference about the trends, looking at the data, and this is capable of doing all those mathematical operations or statistical operations. Now the second team is expert at creating reports, generating summary, right? So now, so this is a typical approach which we would take in such a project, right? So this is exactly what this hierarchical architecture talks about. So at every stage there will be a supervisor. So team manager, let's say the team manager is the top level supervisor. We call it top level supervisor. Now, under this top level supervisor, there will be two more supervisors. Let's say the supervisor one, and it will be a supervisor two. And under these two individual supervisors, there will be two teams working, right? So first of all, we'll have this data analysis team, and second team is the content writing team. And inside these two teams, we'll have different agents. Let's say one agent is expert at creating at statistics, right? Stats. The second agent is expert at finding the trends. There can be many more agents, right? In the content writing team, let's say we have an agent which is expert at some creating summaries. Then we have another agent which is expert at creating reports, right? So this is a typical hierarchical, architecture, top to bottom flow, and at every step there will be sub supervisors or supervisors handling individual teams of agents, right? So that's how we would approach this problem, right? We'll create teams, data analysis team and content writing team. Then we'll assign specialized experts within these teams. So within these teams, we have specialized experts, as in specialized agents for doing specific tasks. and then we'll have supervisors to manage them. So every team will have a separate or different supervisor, right? And then all of these supervisors will be reporting to a top level supervisor who will be like a acting like a team manager, right? So this team manager will assign which team to call first of all, and based on that, then again within this team, the sub supervisor here will decide which agent or which expert to call exactly for a particular task, right? So, so what is this architecture talks about? So this is a way to organize multiple AI agents into specialized teams with supervisors managing them. You know, just like a real world organizations. You know, so that's how the teams are organized, right? In a real world organizations, right? This helps to achieve better scalability, cleaner code, and realistic decision making, right? So in a typical realistic real life problem, that's how a team is structured, right? A complex problem cannot be handled by, let's say, one or two people. We need to have a fully structured team to handle complex projects, right? So we have specialists and, you know, managers or supervisors managing those specialists at every level. So if you see, we will be covering this as part of the project, you know. So we'll be having a top supervisor. Inside this top supervisor, we'll be having two teams: team number one, team number two. So the team one is data analysis team, team two is content writing team, and both of these teams will be having a supervisor again, right? Both of these teams, and then both of these teams have a couple of experts, right? The first team has stats agent, the trend detection agent, and then second team has summarization agent, and then again second agent is, and the second team is report writer agent, right? So this is the typical flow which we'll be looking at in the coding section also. So now let's move on. So that was it in the conceptual part. This was the concept is quite easy to understand, as we saw, as we try to understood this using a real life analogy. So it's always easy to understand via examples and real life analogies, right? That's why I try to explain each and every concept with some real life examples. That was it on the conceptual part. Now let's move on to the coding section. Okay. So here I have already, you know, written the code. I've created the entire flow already just to save some time. So now we'll be starting off with creating the tools. The first tool is the basic stats tool, right? So this will be used by the statistician agent. So now this tool basically takes a list of numbers and returns statistical measures like mean, median, mode, right? So this is pretty simple, right? First of all, we import the required modules for the entire code, and then, you know, we'll be using these modules, mean, median, mode, to calculate these statistical numbers, right? Then the second tool is the trend detection tool. This will be used by the trend detection agent. So here we have written some logic that if there is increasing trend basis this logic. So if the trend is increasing, then it will return upward trend detected. If it's decreasing, it will say downward trend detected. Or if it's not clear, then it will say no clear trend detected. Okay. And I'll be putting all these code inside a Git repository, and you can just access this code and, you know, use it for your own purpose, for your own project or for learning purpose. So now the third tool is the summarize points tool. So this will be used by the summarizer agent. This basically breaks input text into sentences, and then it splits it to create bullet points, right? So again, this is again the simple logic using the split function, and then we are stripping it, and then we are just joining everything together to create bullet points, right? Then the fourth one is the report generation tool. So this tool is basically for the report writer agent. So this is again, we are giving a logic here to take bullets points from the previous tool and generates a simple market research report. So the intro will be like market research report, and then body will be all the points which this function will get, and then it will be end of report at the bottom, right? And we are returning a concatenation of all these three variables. Now we'll initialize the LLM. So here we are using Olama to use the Llama 3.2 model. So we'll be using LangChain Olama module and chat Olama from LangChain Olama. And then here we are testing that if the model is working fine. So if we see model is working fine. So now we'll define the common state class. So this state class will be basically flowing through the entire, these states will be flowing through the entire workflow, uh, you know, uh, across each and every node. Now we'll be creating agents one by one. The first agent is the statistician agent, right? And we'll be using create React agent from LangGraph pre-built, right? So here we are just defining the function, and then we are saying that after this agent is done, it will go back to supervisor. It will give back the result to supervisor, right? Then we are just calling the create React agent. Inside this, we are passing the Ulama model. We are passing the tools. So this particular agent will be using the basic statistical tools, basic statistics tools, which we created above here. The first one, right? This one, right? So inside every agent, we'll be passing on the tool which that agent might need to use for giving the responses. Now we are giving a prompt also. We are saying you are a statistician, do not generate summary and reports. We want to be very specific that this particular agent just needs to do the statistical calculations, and it does not give any, it does not need to give any report or summary, right? And then again we are invoking it using the state. So inside the state we'll be having the human message, right? And then we are going back to supervisor. So once this agent returns the result, it will go back to the supervisor. It will give back the response to the supervisor, right? Then we have the next agent, which is a trend detection agent. This will be basically using the trend detection tool which we created above, and we are giving a prompt that you are a data analysis, you are a data analyst, right? And then again the same thing, we are giving the model, the tools, and the prompt, right? Once this agent also gives the response, it will go back to supervisor again. It will give back the response to supervisor to take further decisions, right? Then we have a summarizer agent. This will basically call the summarize points tool to create the content summary, right? And then we have the next agent, which is the report writer agent. This will be basically taking input and it will be giving back the report, right? Market research report based on the given points, right? Again, this is using the report generation tool which we created above, and all these agents are using create React agent module. So all of these are React agents, right? And then again, once the response is received, it will send back the response to the supervisor again to take the further decisions. Now we'll create a generic supervisor um, node factory kind of thing, which using which will be creating different supervisors, right? So this basically this particular part will be used to create the sub supervisors, right? Because I mean, this can be used to create the top level supervisor also, but in this case I have created the top level supervisor using another piece of code to make it very specific, right? To make it very specific in terms of the flow, because I wanted the flow to be in a particular format, and I wanted to be the top level, and I wanted the top level supervisor to be slightly different from the sub supervisors, right? So we'll be using this particular piece of code to create the individual or sub supervisors, right? So we are giving a system prompt. Your supervisor is responsible for coordinating the following specialized workers and so on, right? And we'll be passing these members. And then we have a router class using which we'll be routing to various workers available. And then we have a supervisor node function, right? So we are saying the supervisor that respects phases, right? And then basically we are also handling the remaining steps to handle the graph recursion limit error, right? So now so this is a basically template for creating the sub supervisors, right? So now let's create the data analysis supervisor. So we are passing the data team members here, statistician and trend detector, and we are just calling this mix supervisor node, if you see here, with the model and the data team member. So this particular method needs the LLM and the members, right? So we are passing the model and the members here. So similarly, we'll be creating the content writing supervisor. So we have the content team members. Then we're calling this make supervisor node function from above, and we are passing the model and the content team members to create the node. Now we'll be creating the data analysis team graph, right? So this is the first team which we talked about. So we talked about two teams, right? So this is the first team now for which we are creating the graph, this particular data analysis team, right? So first of all, we will be adding the nodes. The first node is statistician node, and we are using the statistician agent node function from here to create this particular node. If you see, this is the statistician node, right? So we are using this function to create this particular node. We just go back to the code, right? And then we are using trend detector agent node, and then we are creating the supervisor node, right? And then we are starting the this particular graph by adding the edge between start and supervisor, and remaining things will be handled by the code itself, where we are already providing this command literal, and where basically this node will be pointing to, right? We are already giving that in our code, go to supervisor, right? So now after this, we will be compiling it and we can plot it. So if we see here, this is the first team. So first team has a sub supervisor which is having two experts. One is the statistician, second is the trend detector, right? And each of these agents will be communicating back to supervisor in this particular way. Now we'll be creating the content writing team graph. So this is the second team which will be creating this particular team, right? This team. So now if we go back, so we'll be again adding the nodes, the summarizer node, report writer node, and the supervisor node. And again, we are creating the first edge between start and supervisor, and then we are compiling it and we can plot it here, right? So again, this particular sub supervisor has two agents, summarizer and report writer, and is communicating with the supervisor in this particular way. So now we'll be defining the top level supervisor node. So here we could have used the earlier template, that particular function. But here, just to make it more specific, I have created another code snippet for separately for creating the supervisor node, right? So here we have top team members, data analysis team, and content writing team. So we have two teams. Now we also have this finish option here. Once it is done with communicating with both the teams and it has a satisfactory answer, it will go to finish, right? We have a router which has two options, data analysis team and content writing team. And then see, we could have called the previous function again to create this supervisor node, but here, just to make it more specific, I am creating another uh, code snippet here for this one. So here we are creating the data analysis completed. This is another variable which we are keeping in the state class here, which is the data analysis completed, just to make it just to make the flow such that it follows a typical flow, right? So usually using the React agents, it is very difficult to control the flow because React agents decide themselves autonomously that based on the user query which agents they want to call. But here we want a specific flow, that first we want the data analysis team to be used, and then we want to get the first of all the statistics, the numbers, mean, median, mode, and then we want to get the trend. Basis these two results, we want to create the summary and the report, right? So for that reason, we want to create the data analysis. We want to call the data analysis team first before the content writing team. So for that purpose, I've created this particular variable in the state, and this will be handling this, right? So we are saying that we are creating this top supervisor node, and again we are handling the graph recursion limit error by putting a limit on the remaining steps, and then we are saying that if the state if the value of this particular variable in the state is false, uh, so or sorry, if the value is true, then the allowed workers are the content writing team. So if only if the value is true, right, then only the content writing team will be invoked. If there is no value by default, then it will take the false, right? So if it is false, it means if the data analysis has not happened yet, then it will call, or it will only allow the data analysis team workers to get invoked, right? And then we are giving a system prompt. You are a supervisor coordinating with top team members, allowed team members you can call now, right? So we are just limiting the options available at any particular stage, right? So then we are forcefully intercepting the illegal moves. Let's say, for example, at a particular stage it goes to data analysis not happened yet, and then it tries to goes to the content writing team. Then we are just forcing it that if in the go to is not in the allowed workers, right, then we are assigning, or we are just forcing uh, go to become the first member of the allowed workers list, right? So we're just overwriting it manually, right? And then we are saying that go to is finished, go to end, otherwise this go to update will be go to the next one, right? And next is basically the next agent or the next team member to be called. So now we will be calling, we're creating the function to call the data analysis team, right? So here we are calling the compile data analysis graph, which we created above for data analysis, right? Basically this particular graph, compile data analysis graph, right? So we are calling this inside the call data analysis team function. right? And then we are calling the content writing team. For this, we are calling the compiled content writing graph, which we created above, right? And then we are building the final state graph. Here we are creating nodes for supervisor, top supervisor, data analysis team, content writing team. And then we are first of all adding the first stage between start and supervisor. Rest will be handled by the code which we wrote above, and then we are compiling it. Once we're compiling it, once the compilation is done, then we are ready to plot this graph. If we see, supervisor, the top level supervisor is calling data analysis team and content writing team. Within this team, we have a couple of agents, statistician agent, trend detector agent within this particular team, and also we have a supervisor also inside this team. So within inside this team, we have a supervisor and two agents. One is the summary agent, one is the report creator agent, right? And then we are good to put a query and in this final graph, and then we can see the response over here. So we are asking the query, we're giving a sales data for, let's say, for mobile phones, and then we are saying first calculate the basic statistics like mean, median and mode, then check if there is any clear trend in the sales pattern. After that, summarize the findings in bullet points and create a detailed market research report. This is the query, right? So we are just providing the query in a way that it's very clear to the workflow that it needs to call all these different agents, different team members to get the final response. So if we see the flow now, so first of all, data analysis team is called. It finds the mean, median, and mode, and all the statistical things, right? If you see, the mean is this, indicating steady growth in revenues. It's analyzing also, right? And it's finding other things. Mode, it is finding, right? It is also finding the median. So it found all the statistical numbers. Then basically the content writing team is called. So it calls content writing team multiple times. And then if you see, it is calling the report generation tool, right? Report generation tool. And finally, it gives the report here. The final report is there is no clear trend detected in sales data. The sales figure appear to be increasing over time, but with some fluctuations. This may be due to seasonal or external factors affecting sales and so on, right? So it created a final report here using the report generation tool. Okay, so yeah, that was the entire flow. So I'll just summarize it. So what we saw is we created a hierarchical architecture using LangGraph. We created a top level supervisor. Inside this, we had two different teams. One is data analysis team, one is content writing team, right? And within each of these teams we have one supervisor each, and then within so under each and every supervisor we have a couple of experts. The first supervisor or first team has statistician agent, trend detection agent, and the second team or the second supervisor has summarizer agent and report writer agent. So this was the entire hierarchical architecture workflow, right? So that was it for this particular video. So I have already put this code inside this LangGraph repository, right? So if you just open it, you'll see the entire code over here, right? So you can just go through this code, use this code to create your own project or for learning purpose. Or if you are doing a project on using LangGraph, you can utilize it. You can change it or modify it according to your need, and you can utilize this code. So that was all for this video. So thank you guys for watching this video. If you liked the video, subscribe the channel and like the video and share the video with your friends so that maximum people can benefit it. So please subscribe the channel, guys. So that really motivates me to create more and more such content, for all of you. So thank you for watching this video. I'll be back soon with another video. Till then, thank you.